Morning team. So this video is going through the webinar which we did on the last Friday before half term, so the one on separating mixtures. So we didn't record it at the time because it was a meeting with you guys having your cameras on and giving your inputs, which was wonderful. So unfortunately this video won't include all your excellent participation, but it's just me going through the lesson slides for you to use when you're completing your work. So what I'd recommend you do is watch through this video, try and make it as brief as possible, and then have a go at the work set. So it'll be a Google quiz, and then it'll be some other work as well. Okay, so let me share my screen. Bear with me. Right. I'm going to turn the camera off now. Give me a second. Okay, I guess I'm not, because I don't know how to do that, it seems. Okay, so starting with the lesson. So feel free to make sure you have pen or pencil to make notes during this video. Okay, so we are thinking about mixtures. Now, mixtures is one of those words that we use a lot in everyday life, but in chemistry and science, it actually means something very specific. So mixtures are something that are all around us. So the first question here is getting you to guess what mixture that is all around us. It begins with an A and has 3 letters. So what it's talking about is air. Now, air is actually a mixture of different gases and compounds. So for example, it contains carbon dioxide, oxygen, nitrogen. So nitrogen and oxygen are examples of elements, whereas carbon dioxide is an example of a compound. So you can actually have a mixture of compounds and elements, which is quite confusing, but we have some diagrams later on in this to help you with that. So most things around us are compounds or mixtures. It's very rare that you would find something existing in its pure elemental form unless you're maybe mining for something. Okay, so in this lesson, we are going to be identifying mixtures, and then we're going to be thinking about how to separate mixtures and discussing those separation techniques. So let's think about our terminology first. What are the differences between a mixture and a compound? So take a minute to have a think about this. You can jot down some notes on your paper. Okay, so both compounds and mixtures are made up of more than one element. So that is something they have in common. So when you're comparing two things in science, you need to say the things that they have the same and the things that they have different, not just the things that they have different. So they're both made up of more than one element. In a compound, oh, where's it gone? In a compound, however, the elements are chemically bonded together. So this is normally shown through a diagram. So there's often be 2 different color or shaped atoms connected together, and a new product is made. For example, when carbon and oxygen combine, they create carbon dioxide, which is a completely unique product with its own properties, own melting, boiling point, and so on. In a mixture, they are not chemically bonded, so can be separated. In a compound, the elements can be separated out, but it's much more difficult because it involves breaking of bonds. Whereas in a mixture, that doesn't need to happen. Okay. Oh, so this video, you remember we made a video before on the difference between compounds and mixtures, looking at chocolate buttons. So that video is here for you guys to watch if you're still not sure on the difference between them, but I'm not going to play it now. Okay, so let's have a look at this diagram. So one of these is a compound and one of these is a mixture. Have a think yourself, but pause the video and have a think which one is which. Okay, so the picture on the left is a mixture and the picture on the right is a compound. Hopefully you got that correct. So the mixture is a mixture because we can see that the red molecules and the kind of yellowy green molecules are not chemically joined together. We could easily separate them out by picking them out from each other. However, in the compound, we can see that the green yellow molecules are attached to the red molecules, indicating that they are chemically joined together. So these would not be easy to separate. You'd have to break bonds. Okay, so you may be wondering why they're in pairs. So elements don't always exist in a single atom. They are still an element if it's a molecule that's made up of the same type of atoms. We can see here we've got two red atoms showing together, showing the same type of element, and then two of these green and yellow atoms here showing the same type of element. So it's still elements that exist, just some of them don't like to travel alone. They always travel in pairs. Okay, and you'll learn a bit more about exactly which ones that's the case for. Okay, so here are atoms of an element, individual atoms. So this could be any element, maybe it's nitrogen. Here we have also an element, however, we call them molecules because a molecule is the name for any time you have more than one atom joined together. But because they are the same type of atom, and we can see that because the atoms are the same color and shape as each other, it's still just an element because it's still made up of only one type of atom. Now, if we have a look at C, you can see this is a compound. So we have different colors, so different types of elements joined together, chemically bonded. And then D, it's a mixture. It's got compounds in and it's got elements in. So a bit like air, like we were talking about earlier. Okay, so we have mixtures in our everyday lives. This picture at the bottom is representing air. If you want to know a bit more about the gases in air and investigating those, please take a look at the YouTube video that I put a link there for. So the other two mixtures we're going to talk about today are the mixture that's in the sea, so that's in fact salt water, and also sandy water. So actually often in the sea you get a mixture of salty and sandy water. And they are mixtures because the water is still H2O, made up of two hydrogen atoms and one oxygen atom, and that hasn't fundamentally changed. It's just mixed in with other substances, but it generally still has the same properties and form as water. So bearing in mind our two mixtures that we just spoke about, so salty seawater and sandy water, how could we get drinking water if stranded on a desert island? What else have think about this now? You can pause the video. When we did this live with you guys, you had some excellent ideas. Okay, so we'd be given lots, like I said, sandy, salty water is often what we find. So we need to separate out the water from both the sand and from the salt. Which one do you think would be easier to separate? Do you know of any techniques to do this? So we're going to speak about a specific separation technique. So for your science, you need to learn about particular methods of separating mixtures. And this is one of them. It's called filtration. Now, when we're in the lab, we're going to give you guys a go at doing all these practicals that you've missed. But what you need for it is some filter paper. It is like normally a white piece of paper that you fold into a cone. You may have done it at Key Stage 3. And you put it on a funnel, and then you pour your mixture into it. So your mixture will normally be a mixture of a solid and a liquid. So have a think now, which one do you think this would be most useful to separate? The salty seawater or the sandy water? Okay, hopefully you all thought the sandy water. So that is because our filter paper has got very, very small holes in. The solid particles, so the sand that's in our water, are too big to pass through, so they get trapped. Whereas the water molecules are really small, so they can pass through, leaving you with pure water. However, this only works on mixtures when the solid is not dissolved in the water. So we call this insoluble. So soluble, so write this definition down if you don't know it. Soluble means that it can dissolve in something. So when we talk about soluble, we normally mean soluble in water. So what that means is it can dissolve in water. However, it's really important to be aware that soluble doesn't always refer to water. Something could be insoluble in water, meaning it doesn't dissolve in water, but soluble in another liquid, meaning it does dissolve in that liquid. Okay, but back to talking about this example. So filtration separates an insoluble solid from a liquid. So that means if you have a liquid and it's got solid particles in that haven't broken down and dissolved, that can be separated. So this is because the solid particles are too big to fit through the filter paper. So we've now separated out the sand from our water using this. So take a look at this diagram here. So this sand gets trapped, it's called the residue, and the water that filters through is called the filtrate. However, the salt is still in the water. We still can't drink it. You cannot drink salt water, it will make you ill. However, because the salt is broken down and dissolved in the water, so salt is soluble in water, in the same way that sugar is. So if you think about if you make a cup of tea and put sugar in it and then stir it around, it dissolves in the tea, so you can't see it anymore. And if you were to try and filter that tea and filter the sugar out, you wouldn't be able to, because when something dissolves, it breaks down into smaller particles, so that can also pass through the filter paper. But there is another method that we can use. So this is just going over that definition of soluble. Make sure you've all got that written down. So if you want to know more about filtration, there's a video here that you can have a look at, but we're not going to look at that now. Okay, so on to the salt water. So some of you, when we were discussing it all together, came up with an idea something like this. A lot of you had this idea that we needed to evaporate the water and leave behind the salt, which is absolutely perfect. So obviously something could be left in the sun if you didn't have a heat source, or you could also, if we're doing this in a lab, we would use a Bunsen burner. So you all use them now. A Bunsen burner to heat up our water. However, the problem is that when water evaporates, it just goes up into the air. So then we've lost it and we obviously can't drink it. We're just left with the salt, which isn't very useful to us. But what you can do is you can kind of catch the water. So what happens here, if you have a cold surface above the water vapor, so water vapor is the gas that water turns into when it boils and evaporates, so when it gets higher than its boiling point. While we're here, why don't you have a think about, can you remember what the boiling point of water is? So what temperature would you need to get it to before it would evaporate? So that is 100 degrees. So if we were doing this in a lab, we'd make sure our water was heated up to 100 degrees. And then, oh, sorry, let me go back. We'd make sure our water was heated up to 100 degrees so that it evaporates. Then we have water vapor leaving the salt behind. What you need to do is we then need to make the water condense. Can anyone, or actually all of you, have a think? Can you remember what condensation means? So condensation is when you turn a gas back into a liquid. So you do that by cooling it down again. So when it gets lower than the boiling point, so for water that's 100 degrees, it will turn back into a liquid. So we need to cool it down. So there needs to be a cold surface above it. So think, for example, if there's maybe a bathroom and somebody's had a really hot shower, and then you'll see water droplets on the mirror. So the reason for that is because the mirror is a cold surface, so when the hot water vapor touches it, it turns back into liquid. So it's the same principle here. So what we need to do is we need to cool that water down and make it condense and then collect it again. So in a lab, a scientific way of doing this is using this type of equipment. So I'm going to show you a couple of different diagrams. So this is how we would do it. So we have our Bunsen burner, and it would heat up our liquids. And then what it does is the vapor, so the gas passes along this condensation tube, which is cold. So the condensation tube is like a double layer surrounded by cold water. The reason it has that is to keep the tube cold, so that when the gas hits it, it cools down and will turn back into a liquid. So then your water can travel to the other side and you can collect it. So it will be pure. So that's the way you can separate out water from impurities like salt. Now, distillation can be used to separate a soluble, so dissolved solid from a liquid, or it can be used to separate a mixture of liquids. So if you remember on your work on state changes, you looked up that different substances have different melting and boiling points. So for example, if I wanted to separate out a mixture of water and ethanol, I can rely on the fact they have different boiling points. So ethanol may have a boiling point, I can't remember off the top of my head, maybe one of you guys can, of 200 degrees. So if we heat our mixture of water and ethanol to 100 degrees, the water will evaporate, leaving behind the ethanol. So therefore you've separated them. So the two processes that occur in distillation are evaporation or boiling. So boiling is the point at which it gets to, and evaporation is the process of the water vapor rising. And then condensation. So we need to have both those processes. The liquid needs to evaporate and then condensation needs to happen. Okay, moving on. So if you want to know more about distillation, and actually you all do, So it's a process that's going to come up again and again at GCSE as well. So it's really important we get a good understanding of it here. Can you watch this video that will be attached on the slides as well? Okay, so I wanted to have a think about these. So we did these all together in the meeting. So what separation technique could be used to separate cornflakes from the milk? So pause the video, have a think, you can maybe write it down. Okay, so in this case, it would be filtration because the cornflakes do not completely dissolve in the milk, they stay relatively whole. So if you were to filter it, the solid cornflakes would be separated from the milk would pass through, that would be the filtrate, the cornflakes would be the residue. Okay, next one. Okay, so this is the example I gave you. See if you can remember what separation technique would be used to separate out the water and ethanol. So in this case, it would be distillation because they have different boiling points. Well done if you got that. And finally, okay, stones and water. So have a think about this one. So this one would also be filtration because the stones are insoluble in water, so they can be separated out using filter paper because they're too big to pass through. Okay, now you may have noticed I skipped over a couple of slides in this. That's because we didn't get a chance to talk about them in the meeting, so we're actually going to put them into next Friday's or this coming Friday's lesson instead. So that's about what a solution is and the different names for the different parts of the solution. So don't worry about that part for now, because I'm going to go over it on Friday. So your work for the week is to do a Google form, and then you'll have some extra challenge questions to do. Any questions, please let myself or Ms. Tomlinson know. Okay, going to end the recording if I can manage to do that. Okay, have a wonderful week, guys.